A very good morning from me. I am stateside at the moment, so it was an early rise for me to be able to be here with you at the Festival of the Circular Economy. Today I'm going to talk about how we can harness artificial intelligence, not only for decarbonization, but also for circularity. And I will point out why the two challenges, decarbonization and circularity, are intrinsically linked. I've been told that you can put your questions into a Q&A form, and I will try to answer them all at the end of this presentation. So let me dive into it. Humanity is currently facing two existential risks. The first one is obviously climate change. Here you see the warming stripes by Ed Hawkins. The red stripes represent years with above average temperatures, and you can see since the turn of the millennia we're getting very, very hot, and this could have detrimental effects on human habitat and could actually lead to the extinction of humanity. However, there is a second lesser known existential risk to humanity, and that's the creation of a malignant superintelligence. So advances in artificial intelligence are very rapid at the moment, but we don't know what such a superintelligence, which will eventually be created, will do to mankind. I really recommend the Oxford philosopher's book, Nick Bostrom, on these issues. However, it's not all bad news because we can use artificial intelligence to help us decarbonize. Yeah. There is, however, a problem with decarbonization as well. If we rapidly decarbonize, then we put enormous pressure on resources. Think, for instance, about electrification. We need enormous amounts of copper, cobalt, nickel, etc. Also for renewable energy, we need alloy compounds, etc. This can create, so rapid decarbonization to mitigate climate change can create other problems. And that's why we need this. And I'm obviously not going into detail into this. We need a circular economy. So we have to keep all the scarce resources we need for decarbonization in a closed loop. Yeah? We have to recycle and reuse them. How are we doing on the circular economy? Here, I think a very good visualization from the circular economy, the Circularity Gap Report. And this is the percentage of the economy that's actually circular. And you can see, as you can see, over the last 5 years have actually gone down. Even so, there is quite a lot happening in the realm of the circular economy. And the reason for that is very simply because overall economic growth is outpacing the transition to a circular economy. So the economy is growing faster than we're moving to circularity. So we need every help we can get, including the help of artificial intelligence. And artificial intelligence can do a lot. Here a few quick examples. If you look at grid electricity, responsible for roughly 30% of global emissions, we could reduce that by 15%, according to estimates. Urban transport responsible for 8%, we can reduce by 20%, and commercial buildings responsible for 26% of global emissions by 30%. So you can see we can do a lot in these sustainability areas using artificial intelligence and the optimization it provides. Let me give you a more hands-on example. Here you can see the energy consumption of Google's servers. This was optimized using a software by DeepMind, meanwhile Google DeepMind. And you can see in the first instance, the artificial intelligence managed a reduction of 12%. And over a 12-month period, they could reduce it by 30%. So you can see very enormous reduction opportunities we have here through artificial intelligence optimization. And now we come to the circular economy. The circular economy has been a huge success in many areas. Think paper, think glass, think PET, certain metals such as aluminium or steel. they are all in a circular process right now. I don't think you can buy virgin glass anymore. So that's essentially all at least partially recycled. The problem here is that's all bulk materials. And as soon as we go to items that we need very desperately for decarbonization, for the race to net zero, we're talking about batteries, phones, electric engines. Here we have the cobalt, the nickel, the lithium, the rare earth minerals. Why is it a problem to recycle them? Well, there's a complex collection. Only small amounts are available in the product. The recycling process is hence costly and energy intense, and the materials have to be upgraded. Yeah. But also here, artificial intelligence can help. So by decarbonizing electricity, it will provide us with low carbon energy. So the energy intensity is not such a big issue anymore. Then we have to optimize each step of the circular economy using artificial intelligence. And last but not least, I think a very important point, the artificial intelligence can help us to design products so that they are actually more easily recyclable. Now, how can we extract all the critical metals out of an iPhone, for instance? How can we design the iPhone that this will be possible? Good. There have been enormous advances with this. What you see here is the levelized cost of electricity from photovoltaics, so solar energy. Levelized cost of energy is essentially the lifetime cost, and you can see here that this has exponentially decreased over the past decade. If we compare this to 2010 estimates, you can see that we've beaten those estimates by a long margin, actually by 82%, and solar power is now below the cost range of fossil fuels. Yeah, so we completely underestimated what we can do. Why is that? Because we have a virtuous circle. So what I already mentioned, artificial intelligence is helping us to improve the production process of PVC cells or of solar cells. And with this, we get more low carbon energy online. We make them cheaper, more affordable, and we make them more low carbon, which gives an incentive to install them. So we have a very clear virtuous circle here. And what makes this possible is, again, something that has to do with cyber-physical systems and artificial intelligence. It's the Industry 4.0 setup. So this helps us to produce these items at lower costs. Good. And this brings me to the conclusions already. Here we have, again, the circular economy as set out by the European Union. And we'll have AI help us design products so they can be more easily recycled. That's here in the sustainability design. Then moreover, as I just mentioned, in the case of photovoltaics, Industry 4.0 can help us optimize the production, so reduce the carbon footprint of the reduction. Moreover, it will help us to optimize distribution of goods. The logistics sector was one of the first sectors because it's highly complex to apply artificial intelligence and machine learning. Now, last but not least, the circle you see on the left-hand side is very energy intense. Yeah. So if you really want to drive towards a circular economy, we have to decarbonize electricity because it's the most important input factor to this. Yeah. And as I already mentioned during the talk, the decarbonization of energy provision has to go hand in hand with the move to the circular economy. So on the one hand, we need a lot of electricity for the circular economy. So we have to decarbonize the electricity. On the other hand, we need many scarce materials, again, copper, nickel, cobalt, lithium, rare earth metals, to get decarbonization to work. And these are scarce, so we can't produce them as virgin materials all the time. We have to move them into a circular economy. The good news, however, is that by doing this in parallel, so driving decarbonization and a circular economy, we'll create the virtuous circles that I've just mentioned. And this can really help us to tackle the sustainability challenge holistically. Very good. And this brings me to the end of my presentation already. I thank you for your attention. In case you want to look into these things in more detail, I recommend our book, Intelligent Decarbonization: Can Artificial Intelligence and Cyber Physical Systems Help Achieve Climate Mitigation Targets, published last year in a collaboration of Springer Nature and Cambridge Cares. Perfect. And now I think we have sufficient times for questions and answer. And I have here a very interesting question from Sophie. I'm just going to read it out. Can you give some examples of AI use, companies using AI, or how they are doing the AI to achieve all these reductions? Yes, absolutely. Coming back to the example I gave from Google. So Google is now optimizing all their energy use with artificial intelligence, and as you have seen, we can gain reductions up to 30% already. I've also mentioned the logistics sector. Obviously, here getting goods around more efficiently is key to their business success. So they likely have utilized this to optimize their business operations and improve the bottom line. But obviously, as a side effect, you also increase sustainability of this. The next example I could give is the optimization of grid electricity. Yeah, if we want to move to a smart grid, then in the end we need artificial intelligence, and there are many great companies, from big players to startups, working on exactly this. Yeah, how can we move our old grids to a smart grids, and artificial intelligence will be key to it. Another industry that I think is very interesting is chemicals, the production of chemicals. So here you have an asset heavy industry. Once you've got one of these reactors in place, it will stay there for decades. And usually you're then in a lock-in situation. So this reactor will just emit until it comes to the end of its lifetime, which can be decades. However, with digital means, cyber physical systems and artificial intelligence, you can actually improve these reactors that usually would be high emitters for the rest of it. So there are numerous examples for this. And at the moment, I think if you want to stay competitive, you have to employ artificial intelligence. Otherwise, you'll lose out to your competitors. Another question, can AI detect chemical compositions of materials? Absolutely. There are examples for this as well. And not only can it detect the chemical composition, but it can help with sorting of materials in the recycling process. As I've said earlier, the collection and determination of what kind of waste we have will be critical, and AI can help us. I think during this conference yesterday, there was a talk about exactly that, how AI will help in waste management. And I think there is many things where I can help. So another question from Naomi, how do you think AI will affect employment? Will less people be needed in the future? Oh, that's an excellent question, very high level. I think that definitely AI will reduce some opportunities, job opportunities. Think, for example, call centers. Yeah, call centers are now being replaced by chatbots, many things. However, I think personally that we also create a lot of jobs, and that AI will help us be better at our jobs. what I think is critically important here is that we get kids to be computer literate, that they not necessarily have to code, but know how to work well with computers and how to apply AI in their jobs. And then we can really move forward with this. Thing is, there will be job losses by AI. That's very clear to me. And another question by Martin. A good point about reactors and lock-ins. Once you have a long-term product, you are usually stuck with it and a lot of associated activities, and can be very, how do you avoid that trap? Oh, that's also something where I can help. I've spoken about how I can help us to design products that they're more easily recyclable. That's a very critical, important point. But we also use artificial intelligence to build scenarios to avoid this lock-in situations. For instance, you're planning a new transportation system or a new plant, industrial plant. You can go through various scenarios and pick the optimal one, and thereby avoid lock-in situations. Yeah. Also, I've spoken about the lifetime extension that you have for huge industrial plants. Also here, artificial intelligence can help. So there's many, many things artificial intelligence can do. Okay. Just waiting for more questions. No, in this case, I'd like to thank you again for your attention, and it was very good speaking to you, and many thanks for all these excellent questions.